Review of final assessment, solving, continued. Question number 4 has 5x to the second power minus 17x equals 12. We want to solve this problem just like we did the previous problem. So to solve this problem, we're going to subtract the 12 off both sides, which gives us a 5x squared minus a 17x minus 12 equals 0. In the A position we have a 5, in the B position we have a negative 17, and in the C position we have a negative 12. What we're going to do next is take the A times the C. So A times C gives us 5 times negative 12, which equals a negative 60. In the B position we have a negative 17, so we want a pair of factors that when multiplied together make a negative 16, but summed together to make a negative 17. If we were to run through our factors, 1 times 60, 2 times 30, the next one would be 3 times 20. 3 times 20 makes a 60. And in this one, if I put the negative on the 20, it makes my negative 60. But on the other side, a 3 plus a negative 20, it makes my negative 17. So there's my pair of factors. I'm going to plug these factors in and replace the negative 17x to the center. So let's come down here. So I have my 5x squared, and since I've got a 5 there, I'm going to put my 20 there. So I'm going to put minus 20x plus the 3x minus the 12. I'm going to put in my grouping symbol, so put in my parentheses. In the first pair, I have a 5 and an x in common, so I'm going to pull out the 5x. 5x into 5x squared leaves me with an x. 5x into a negative 20x leaves me with a minus 4. On the other side, I have the 3x minus 12. What they have in common is a 3, so I'll divide out a 3. So 3 comes to the outside of the parentheses. 3 into a 3x leaves me with just an x. 3 into a negative 12 leaves me with a minus 4. So now what they have in common are the x minus 4 and the x minus 4 from both sides. So I pull those out. I divide them out. Once those are gone, if I ignore the x minus 4, once I've divided them out, I'm left with the 5x plus 3. So I put that into the next set of parentheses, 5x plus 3. Now I need to set each of these equal to 0. So x minus 3 equals 0, and 5x plus 3 equals 0. On the first one, I'm going to sum 4 to both sides, so I find that x is equal to a 4. On the other side, I'm going to subtract the 3 off, so then I'm left with 3x equals negative 3. Lastly, I'm going to divide it by a 5, so I end up with x is equal to a negative 3/5. Let's go down and look at problem number 5. The instructions read, solve the system of equations using the elimination method. So I have an x minus 3y equals a negative 18, and a 5x minus a 3y equals a 6. So I want to solve this problem using the elimination method. So what I'm going to do is try to get one of these so that I can, when I sum them, I end up canceling out either the x's or the y's. Well, when I look at this, they both already have a minus 3y, minus 3y. If I can change one of those to a plus 3y, then I can use the elimination method and it'll cancel out. So what I'll do is I'll take that first one, that x minus 3y equals negative 18. I'm going to multiply it by a negative 1. As long as I multiply every term by the same value, apply that to every one of the terms, I'm not going to change the problem, or the value of the problem. So I end up with a negative 1 times an x, a negative x. A negative 1 times a negative 3y, a positive 3y. A negative 1 times a negative 18 to make a positive 18. Now I can take this new one and plug it in with the second formula. So I'll put them both together. So I have a negative x plus 3y equals 18 with a 5x minus 3y equals 6. When I sum these down, a negative x plus a 5x makes a 4x. A 3y plus a negative 3y equals a 0. And an 18 plus a 6 creates a 24. So I have 4x equals 24. I'll divide the 4 out to find x. So divide the 4 into the 24 and I get a 6. Now I can come back and take the original first value, or first equation, x minus 3y equals negative 18, and use the x equals 6 to find what y is equal to. I plug it in, I end up with 6 minus 3y equals a negative 18. If I take the 6 and subtract it from both sides, I end up with negative 3y equals a negative 24. Lastly, I'll divide by that negative 3, both sides. Negative 3 into a negative 24 makes an 8. So now I know what y is. So x was a 6, y is an 8. Make sure that you put those in parentheses. Those are an ordered pair. They're a point on the line. For number 6, the instructions read, solve and check. Identify any extraneous situations. So I'm going to solve this thing out, then I'm going to check the problem, see if it's correct. So I have here a 3 over a y to the second power minus 9 equals a negative 2 over a 3y plus 9. So anything that I can factor, I'm going to factor first, pull it apart. When I look at this first set, a 3 over the y squared minus 9, this is already squared. If the 9 will square, then I can use the difference of squares to rewrite the problem. And it does. A y squared minus a 3 squared is the same thing as y squared minus 9. So that means I can use a difference of squares. So I could take these bases and write them into the conjugates to factor it. So I have a 3 over a y plus 3, y minus 3. On the other side, the negative 2, it's going to copy down the same, but I see that the 3y plus 9 have a 3 in common, so I can divide that out. So I'm going to divide the 3 out. What that leaves is a y plus 3 to the inside of the parenthesis. Now, what I can do is come back in on the problem and multiply this thing by the lowest common denominator between the y plus 3, y minus 3, and 3 times y plus 3. There I have the y plus 3's in common on both sides. So the other things they need, if we look over here on the left, we still need a 3 for this one. And if we look over on the other side, we also need a y minus 3. So the lowest common denominator is going to be everything that we see present here multiplied to it. So a 3 times a y plus 3 times a y minus 3 combined together. So I'm going to multiply these together. So I'm going to set it up. 3 times y plus 3 times y minus 3. 3 times y plus 3 times y minus 3 on the other side. Multiply both sides by the lowest common denominator. What this is going to do is make a situation where I can do some canceling. I have a y plus 3 and a y plus 3, those cancel. Y minus 3 in the top, y minus 3 in the bottom, those cancel. So that when I pull those back together, what I've got left is a 3 times a 3, and then a 1 times a 1. So I end up with a 9 over 1. On the other side, do some canceling as well. 3 and 3, the y plus 3, that cancels, so I'm left in the top with a negative 2 times a y minus 3 over 1. So simplifying that, I have a 9 equals a negative 2 times a y minus 3. I can now distribute the negative 2 through the parentheses to simplify. So I get a negative 2y plus 6. Now I'm going to subtract the 6 off both sides. Minus 6, minus 6. I end up with a 3 equals a negative 2y. Lastly, I'll divide by that negative 2, and I end up with y is equal to a negative 3 over 2.